Alright, what we're looking at now in this last section of this second block of calculus is on differential equations. If you think about the words, differential, obviously involving derivatives, and equations, okay, then they're equations that have derivatives in them. Okay, what we're looking at essentially is that a differential equation is an equation, okay, that contains at least one derivative. And we've got first order DEs, or first order differential equations. They involve first derivatives only. A second order differential equation would involve second derivatives, but can also have first derivatives. Okay, now the first part of what we're going to be looking at is in verifying solutions. Okay, just confirming that a certain result is a solution to a particular differential equation. And so in our first example here, a fairly straightforward one, we're told that y equals x minus 2 all cubed, and we need to show that that equation is a solution, or that result for y is a solution to this differential equation. Okay, we don't normally think of dy dx equals something like this as being a differential equation, but it is. Okay, because it's an equation that has an equals sign and it has a derivative, dy dx. Okay, now in order to show that this here is a solution to this differential equation, we can simply go ahead and, well, we're starting with this expression or this equation, and now we're going to differentiate. Okay, so we differentiate both sides with respect to x. Okay, or just simply find the derivative. Differentiate y with respect to x. So left hand side we can write as dy dx. On the right hand side, okay, take 3 out the front, so it's 3 times x minus 2, reduce the power by 1, and of course we would, applying the chain rule, multiply that by the derivative of the inside part, which is simply 1. Okay, but we won't worry about putting that down. And then we can go ahead and expand that because we want to see whether this is the same as this. Okay, 3 outside of, now expanding this binomial product, x squared minus 4x plus 4 equals, expanding, 3x squared minus 12x plus 12. Okay, and that we can see is the same as that. So we could write QED, which means quod erat demonstrandum, which is Latin for which was what was to be demonstrated. Okay, and it's quite common to have something like that in a proof. Okay, we could simply say, therefore, y equals x minus 2 cubed is a solution to dy dx equals 3x squared minus 12x plus 12. Okay, so that's a fairly, I guess, typical sort of question that you'd be familiar with and wouldn't have been difficult to work through. Let's look at another example. Okay, so verify that y equals x root x is a solution to 4y times y double dash, or the second derivative, equals 3x. Okay, so we need to verify that that is a solution to that. So what we're going to have to do is, first of all, just consider what we have been given. Okay, consider y equals x root x. Now that's the same as y equals x times x to the half, which is x to the 3 over 2. Now, we need to have involved here the value, the expression for y, but also the second derivative of y. So we are now going to go ahead and find the first derivative, y dash, and that's going to be 3 over 2 x to the 1 over 2. Alright, and then we can find the second derivative, which is 3 over 2 times 1 over 2 times x to the negative 1/2. Or let's go a little bit further, that's 3 over 4 times x to the negative 1/2. We could leave it like that, okay, or we could write it as 3 over 4 x to the half, or indeed 3 over 4 root x. Okay, so we have an expression for y, we have an expression for the second derivative of y, and we have here our differential equation, 4y times y double dash equals 3x. So, given that 4y times y double dash equals 3x, we work through that. The left hand side equals 4y times y double dash. That is equal to, well, and actually, and I'll just write over here, right hand side equals 3x. Continuing down the left hand side, that's 4, and instead of y, we're going to write x to 3 over 2 times y double dash, and I might even just write it in this form here, okay, 3 over 4 times x to the negative 1/2. And working through it, we can see that the 4's are going to cancel, and we're going to be left with 3 x to the 3 over 2 times x to the negative 1 over 2, and then we add together the powers, okay, 3 and 3 over 2, power of 3 over 2 minus 1 over 2 is going to be x to the 2 over 2, or just x to the 1, or just 3x, okay. We can see then that that is equal to the right hand side, okay, which was what was to be demonstrated, okay, QED, and there's our result. We have verified that that is a solution to that differential equation, okay. So we needed to have an expression for y, for the second derivative of y, and then put them together on the left hand side and work through the left hand side to prove that it's equal to the right hand side. That is the best way and most elegant way to work through a problem like this, where we need to verify something or prove something. Okay, work down the left hand side, show it's equal to the right hand side. Okay, we're going to work through another one. Okay, so our third example, find the value of k if y equals e to the kx satisfies the differential equation y double dash minus 4 y dash minus 5y equals 0. So in this differential equation we have a second derivative, we have first derivative, and we have just y as well. Now our value for y, or our expression for y, is e to the kx. Y dash, therefore, the first derivative is going to be k e to the kx. And our second derivative then is going to be k squared e to the kx. Now, we have y double dash minus 4y dash minus 5y equals 0. Let's substitute in. Okay, we have a value or expression for y double dash, that is k squared e to the kx minus 4 times y dash, which is k e to the kx, minus 5 times y, which is e to the kx, equals 0. Now, let's work through from here. We've got a common factor here of e to the kx, so we're going to take that out the front. E to the kx, leaving us with k squared minus 4k minus 5 equals 0. We have a quadratic equation here, so let's factorise that, or quadratic. Okay, two numbers that multiply to give negative 5 and add to give negative 4. That's going to be negative 5 and 1. So we've got e to the kx times k minus 5, k plus 1 equals 0. And we have here an opportunity to use the null factor law, because we've got three factors multiplying together to give 0. So that means e to the kx equals 0, or k equals 5, or k equals negative 1. This result here is no solution, and so we're left with just k equals 5 or k equals negative 1. And there are our results. Okay. That then is basically the introduction to this subtopic. Okay. And so what we can do is work through. There are a series of problems in exercise 7b of the text, page 313. Okay, so work through those. That's on this area of verifying solutions.